Hello, this is Tanner Tech, and in this live stream today, we're going to be taking a look at this old Zenith transatlantic radio. I think it's pretty cool. It needs a little bit of fixing up, but I think we can probably get it running. Let's get started. So I see I already have 5, 6 viewers or something, and quite a few likes. That's pretty cool. Well, let's fire up some lights on this radio and crack open the back. See what we can do. There we go. So this is a really cool old radio. It's an old Zenith transatlantic radio. Now, it's got quite a few different settings. It's got a volume knob right here. When you turn the volume knob all the way down, it's supposed to make this little red indicator go away, but the red indicator is still there. And you have the tuning button, of course. We have quite a few different bands. You actually have 6 different bands you can go on. You can go on the 49 meter band, 31 meter band, 25 meter band, 19 meter band, 16 meter band, and typical broadcast, which covers the kilohertz spectrum. So it's like you got 640 kilohertz, which is KFI AM 640. That's how you can get that radio. Then you've got these other things to fine tune your radio for certain types of things. You have different switches that you can turn on or off. These switches are treble, voice, alto, and bass. So that's basically the tone selector. So instead of a tone knob, you have this. And yeah, this radio has everything except FM. So on the bottom there's this cool little compartment that has this instruction manual on it. So you have this really cool vintage map of the world time map. It shows you the times at every part of the world, in every time zone. You've got best reception in different parts of the day on here, and this is basically some ham radio stuff, where some bands work better in the nighttime, some work better in the day, so it tells you all that there. And you can record which stations you hear at different places on this little chart. On here we have this list of United States channel stations, and this thing looks pretty cool. Got all these different channel stations you can tune into. I don't know, this thing is pretty cool. It tells you how to use the radio. Now, the interesting thing is it says this radio has a battery, which is pretty strange. I guess it is a portable radio. Some operating instructions about how to open it up, battery installation. The split second scale just on the scale so you can tune it more finely. Tells you how to use the tone knobs. Tells you what tubes are inside here. Now this is interesting. So it has 1 LN5, and all these tubes are 1, so they're all 1-volt tubes. So we have an RF amplifier, mixer, IF amplifier, the second detector, the inverter, and 2 push-pull amplifier tubes, and a rectifier. So that's pretty cool that it has push-pull tubes. That makes this 8-tube radio. So yeah, there's this little thing. It tells you how to attach the different antennas in this device, which it actually has quite a few different antennas. So let's close this up and crack open the back. So if you may have seen on the top right here on the case, this thing is actually an antenna in itself. So it's kind of falling apart a little bit, but these 2 metal bars are connected to power for the antenna. You got a loop antenna up here, Zenith. Let's flip this around so we can crack open the back. Hopefully we can get this radio running. And I think the cord is in the back. Oh, there we go. Consider it cracked open. We got a wide variety of tubes down there. Wait just a second, I gotta chat. Output seems to be getting worse. Is my live stream working, guys? Can you tell me in the comments if the live stream is looking good or not? Well, anyway, we got some interesting things down here. So we have this, and this looks like it's a strap for batteries or something. I'm not exactly sure what this strap is for. The resolution's low. Crap. Oh, was that bad? Oof. Let me try something. cable right here. I'm thinking this cable connected to the battery or something. It's very interesting. We'll hook that cable up where it belongs. I can't even put this cable back together. Put this cable where it belongs. So this is interesting. This is a loop antenna that actually comes out. And you can, I think you can pop it out too. Or not. Anyway, it's a loop antenna you can pop out of the back of the radio. So that way you can have better reception on the shortwave bands, which is really cool. And it has a tuner inside here. You can use to tune it. And there's a little number knob on here that you can use to select between the different bands that you want to tune for. So that is pretty cool. There's a lot of different tubes inside there. Almost all these tubes are the 8-pin octals. Then you've got this tube right here, and that tube is not one of them. This tube has 1, 2, 3, 4, 5, 6, 7, 8. Okay, what is this tube? This tube seems to be the 117Z3. Yeah? You have 2-tube radios? Well, this tube radio right now, I'm fixing for somebody, but 2-tube radio sounds pretty cool. Thanks, dude. So we've got this 117Z3 tube radio. Vacuum tube. This looks to me like the rectifier. That's a pretty small rectifier. Look at that. I'm going to set that aside. We don't need that right now. Let's work on pulling out this whole chassis. I'm going to back this up. Thanks, man, for the $20 donation. That's pretty cool. I'm just trying to get this thing to focus on the exposure. Well, I don't know what's wrong with it. Okay, first of all, let's take a look at this cord. This cord is a real mess. So you got this cord right here, and the cord is duct taped together, and it's coming out of the cord holes. And you can see that there is some issues with this cord just right here. It's just falling apart. Like, even when I just bend the cord, it just crumbles and falls apart. And just the inside open. So I don't want to plug this in because this cord is a giant hazard. And even the plug on the front right here is pretty bad. Look, you can see that there's copper touching each other all everywhere in here. If I were to plug in this cord, this whole thing would probably blow. We also have the battery cord right here. The battery cord's even worse. I don't even want to play with this. Yeah, I probably need some replacement of some capacitors too. But look at that. Oh gosh, that's horrible. The battery wires, because this is the battery connector right here that connects to some kind of battery. But that just looks bad. And apparently, with this tube radio, and you want to switch it to battery power, you plug the AC connector into here. Which is cool. So, let's remove this chassis. Oh, this thing is just horrible. I think first of all I have to remove this antenna because this is going to get in the way of me taking out the chassis. I'm not sure how that's going to happen. I need a flathead. Singing robot? Yeah. Someone said, how's a singing robot project going? I forgot about that, I'm sorry. I remember I once looked into finding singing robot stuff, but didn't get much of a chance to do so. Alright, I think I can just take out the bottom. I'm just going to close this up kind of and flip it around, because in order to take out the chassis, you have to unscrew the bottom. Oh. Alright, as you can see, there's screw holes right there that connect to the chassis. So I'm going to have to get my long flat head. Now, I really don't... My stupid fume extractor is in the way. I really don't want this chassis to fall forward. I think it should be fine. Okay, here's one of the screws. Thoroughly loosened. Let's get the next one. Crazy, there's only 2 screws holding this chassis in, and one of them's loose. Alright, let's take this chassis out. Oh! First things first, I need to take off the potentiometer knobs in the front. Forgot that back. This thing's a beast. See, gotta remove these pot knobs in the front. Oh, that just fell. Put that next to the tube. Let's take out the chassis now. This antenna is blocking the way. Maybe if I take it out, I can just slide it out of that little bottom thing. How can I take out this antenna? I think it's been nailed on there. So I can't remove the rest of the chassis until the antenna's out. Let's see. This is some tricky business right here, guys. Yeah, I have an old brown extension cord I'm going to use. I need to get this out. Can't remove the chassis until this is out. This whole thing's magnetic. Maybe I can remove the chassis. No, this is not working. Oh, there's like screws missing in the top. There's a little schematic down there. I love the smell of whole electronics. I can unplug this antenna. Oh, cool. I can unplug 2 of these antennas. Here, they're me. Okay, guys, help me remember this. So, the tall antenna goes into this antenna slot. And this one goes into that antenna slot. Sorry the image is so washed out. It's annoying me, too. Looks like someone went in and fixed this thing with duct tape. There we go. Easy peasy. So I got the antennas unplugged from the chassis. Now the big issue is taking it out. See, the buttons are connected in here. Well, there's a good old wax capacitor down there. The antenna's in the way. Oh no, there's this block in the way. What the heck? What in tarnation is going on here? Someone put a block in the way right here. No wonder I can't get it out. This wonky block is blocking everything up. Now I should be able to take it out easy. Not sure why that was in there. Nothing. Oh gosh. Alright, I'm gonna have to sit this on the floor because this is not working on my desk. I feel like it's gonna f at any time now. Okay. This thing wouldn't be hard if this stupid antenna wasn't in the way. I don't really know how to take it off. Cool. Okay, so I'm still having trouble getting this chassis out. The stupid antenna is in the way. But they made it really tricky to take out the antenna, which is kind of odd. Where's my dog? It came in the dog door. My door is shut so the dog can't get out. Great. Come here, dog. Okay, here, let me bring it down so you guys can see better. Maybe you guys got an idea. So, this antenna right here, it pops down, and this screw just holds on the little clip lock. So you just press this button, and the antenna comes up. So that's all that's for. But down here, the antenna has this weird white thing around it. And this weird white thing holds it in. And way back here, there's two screws that are coming out. Which means that I think before they put this leather backing on, they did something. It makes this antenna a real pain in the butt to get out. Oh, look, we also got another plug up here, sound plug. Great. We got 50 plugs down here. And I can't get out this thing yet. Okay. Come here, dog. Want to help me with the tube radio, Chloe? Come here. Come here, Chloe. I'm trying to get Chloe to help me with the tube radio. Chloe. Yeah, the weird white part is metal. It won't come out. You know, I'm gonna get some big pliers. Maybe this will help. That white thing's stuck in place pretty good. long as it's meant to come out. Oh, there we go. Easy peasy. Alright, let's bring this up to the desk. Ugh. So many dead bugs in there. Alright, here we go. Exercise much caution. Okay. Set this case there. There we go. We got it out. After much tribulation. Chloe. Alright. To figure out what's wrong with it, we're first going to let Chloe sniff it. Come on, Chloe. Can you tell me what's wrong with the radio? You want to? Alright, she doesn't know how. She's not a tube radio expert. Let's flip this around. See what the front looks like. Awesome. That looks so cool. Looks even cooler in the front. And let's put this little dial on it. That's a cool on and off switch. Look at that. Okay, so someone asked where this radio came from. So, a client asked me to fix their tube radio. It's a family heirloom, and they wanted to get it running again. Wow, that's cool. Check this out. So, this thing has a switch. Notice this little black line right here. When you turn it on, it turns to red, and that means your radio is running. When you turn it off, it turns off. Cool. This one definitely goes here. That's cool. Let me take these off again. Oh, sick. Look at this. There's like... Oh gosh, what's happening here? Oh boy. This is gonna be a fun job. Look at all those capacitors. They're all oily. Nasty. The electrolytic capacitor is probably bad. Bet it is. Everything in here is corroded. Oh, there's chunks falling out of it. It's like these wires are... Oh, gosh. Look at these switches. They've got white powder around them. So, look at that. They've got lots of this powder around them. Look at that powder. That must have just been decomposing. Oh gosh, look at this. So these are the buttons they're used to press in and out to select the different frequency bands, and all the mechanical aspects of this work perfectly, which is really good because I don't want to fix that. But look at all that corrosion. Gosh. Just a second. I'm gonna be back with like a tissue or something. Alright guys, I got some wet paper towels. We're going to use these paper towels to kind of clean up the radio. Yeah. Look at that. Look over there. This thing is just covered in that white powder. And look at the white powder, it just drips on my desk. I don't even know where that came from. Sure is nasty though. Chloe, calm down. I'm making a live stream. That's my dog whining over there. You see, I closed my door so I could do this live stream without any noise interruptions. The dog came into my room because that's the only doggy door. So now she's mad. I wonder why there's so much rubbish on here. Gosh. Oh, yeah, today I tried to do a live stream earlier in the day, because I know I typically do live streams like late at night, my time, and I'm in Pacific time in California, of the west coast of the United States. So I know that probably screws up a lot of people. Okay. Let's lift it back up. So, if we look at the speaker, there's this line in the side. Now, this line means someone has already fixed it. Because typically speakers don't have a line like that. And with this line here, it means the speaker rips and someone reconed it. But we're lucky the speaker is intact. That's good. Oh, we got two electrolytic capacitors right here. That one. That one. Those electrolytics are for sure bad. We have to get rid of those first before we can do anything else. And we also need to replace these horrible power connections. Gosh. So, that should make it easier for us to replace. We've got the power connections along... If you look over here, we got the power connection right here. And it goes through these little holes and it's soldered on there. So we can literally just chop those off and put a new power cord on there. Just a second. I don't know where my cutter is. This cutter should do fine. Oh, gosh. Oh, gosh. These wires just fall apart. This plug cord is destined for the trash. Destined for the trash. You know what? I'm not going to completely kill this power cord, because I like the look of this power cord. So I'm going to try and do is I'm going to unscrew these parts of it. And remove the wire. We have to unscrew them all completely. Okay, cool. I saved the little plug. Alright, so the plug is saved, apparently. And I can use it again to work again. Maybe I'll use the same plug with just new wires going into it. Yeah, you're right, this plug wouldn't pass compliance. I mean, passed compliance a long time ago. It still looks kind of cool. Okay. So we've got a mess of caps down here. All these caps are Zenith. These are all original. The real pain in the butt is going to be installing a new electrolytic. Especially because I don't know what type it is. I'm going to have to look up a schematic for it. I hate new electrolytic installs. I hate them. Especially when they don't tell you anything. That's going to be a tricky one. Any new comments? Yeah, so these are battery wires right here. They're all corroded. But there's a switch down here. What the heck? There's a switch? That's strange. Yeah, look at this. There's a switch down here. There's an actual switch in place right here. No, this radio doesn't have circuit boards. This is interesting. There's a switch. Look, I can... A weird switch. Why do they have a switch right there? Oh, I know why. So with the switch, yeah, what happens is when you plug in that switch, if you look on the top right here, there's a place for you to plug in your plug cord in the top. And when you plug in that little plug cord, then it flips the switch and preps the device to be used for battery. Okay, I think all these tubes look pretty good. How do you say pull the cardboard out? Do I just, like, break them? Oh, it says on this side. Just a second. Okay, Chloe, you can go. You can go, come on. Sorry, my dog needs to be let out. So we have an electrolytic right there and over here too. Okay. So I got the plug switch taken care of. I just want to get rid of these ugly looking battery wires that are falling apart and that are a safety hazard. No, I want to get a schematic for this first. Well, yeah, but if you look at the capacitors, the capacitors are kind of like bent into place. Okay, that capacitor's almost ready to come out. I'll have to work on some desoldering it. Let me turn on my soldering iron. Let me take some pictures of what this looks like, so that way I remember it for later. get a flash in there. So you got this top one coming from a high voltage resistor in the back, and it goes right there. We got this wire going from the second part of the high voltage resistor to the one end of the capacitor bank. Got our third wire going, the orange wire, to one end of the capacitor bank. So there's 3 capacitors right here. I'm pretty sure this is ground. Let me just verify with my ground meter. Okay, where does this wire go then? Is nothing grounded in here? Just... What the heck? Okay, where does this wire go? Okay, that one goes there. What the heck? It seems like it goes to the switch. Yeah, it goes to the switch right here. And that also goes... Oh boy, to the other electrolytic capacitor. So I think that's the common node for all the electrolytics. Just a second. I need to get a schematic for this right now. I also want to remove this hideous abomination of wires. These wires are not necessary anymore. Oh boy. Where do these wires go? How can we kill them? So we have the red and the orange wires. Go to these parts of the switch. The black wire goes somewhere. Was that a little hole? Was that the... Goes to the speaker. What the heck? Oh, crap. That's the speaker wire. And it's falling apart too. That's not good. All the internal wires are falling apart. So we have only 4 wires coming in from this thing. So we have 1, 2, 3, 4, U. Well, let's take them out. Let's get a picture of that first, too. Hope this is entertaining to you guys. It's fun to me. I find it necessary to document all this part before I remove them. Battery service is not necessary anymore. Oh gosh, what was that sound? That does not sound like a good sound. No. I guess it's fine. Put it at the source. Got those two wires out of the way. Find out where these two go. These wires are so brittle. Okay, where does the other wire go? Let's trace it. This wire is surprisingly not falling apart. Oh gosh. Oh, I just killed that wire. Let's take a picture of where that other battery wire went. The blue one went there. And the black one went there. Okay, let's kill him. Very carefully. Blue wire has been freed. Okay, I think I've freed all the evil battery wires. Okay, let's dump out the wire trash. Oh boy. Scrape that up with a Lowe's receipt. It's time to get rid of all these bad wires. Toxic wires. I got the battery lead out of here. Okay, now I've fractured one of these wires, and I'm kind of sad about that. I need to find out where it goes. This is the ground to one of the, it goes up there. Dang it. This one goes to the speaker. actually, this lead may not be used because this goes to the speaker. If this black lead goes to the speaker, that is the speaker already has power coming to it from the audio transformer. Because you have the audio output transformer on top of the speaker. So where does that yellow wire go? And theoretically that black wire shouldn't matter if I cut it, because it just goes to the speaker. Yeah, that's the only thing connected to it. I'll make a note of that. See if I can pull it out the top. Probably fracture this and all the other wires along with it. Gross. Ugh. Sick. Making a mess. Vacuum is going to be necessary right now. No, a lot of these things stay good. Gosh. Okay, this wire is bad up here. I'll disconnect this. Hopefully I won't need it again. Oh crap, there's a piece of wire that's about to fall to the speaker. My hands are all nasty from this job. But I think we have some progress going on here. Along with this pile of radio fart. Okay, let's flip it around. From what I can tell, all the tubes are in good shape. They haven't aired out. It's a good sign. The bad sign is that the electrolytic caps are a real pain to get to. I'm gonna get the schematic of this pronto. These tube radios are a real pain to get into. Just merely because there's so many parts blocking the way. Since there are no circuit boards, everything is way cramped up. Just a second, guys. I'm gonna take a quick look inside the radio again. Yeah. Alright. So guys, I found something interesting in here. Check that out. Inside the radio. What does prep work mean? Yeah, there's prep work that needs to be done here. I can't read these, it's so small. It says values of capacitors and stuff. I think. Well, at least it says tube types. I'm gonna find a schematic for this thing. I'm halfway tempted just to fire it up right now and see what happens. And then it can't be that bad. You guys think it'll hurt it if I fire it up right now? The issue is the capture uses like facing grounds for... Yeah, you're right. Prep work would be good, but I kind of want to just take you through jumping in this thing straight up. There's so much wax on everything. Trying to figure out how to get these caps out properly. This cap shouldn't be much of an issue. This cap should be a real big issue. I'm gonna grab my laptop real quick. This way, and find a schematic. I'll be right back. Alright, here comes Tannertech to the rescue with schematics on his laptop, hopefully. Got the laptop all fired up. Get a schematic of this thing. So this is a Zenith. This is a Zenith. What model is it? Give me a second. Just a second, guys, on the live stream. I'm looking for the model number of this rig. There it is. Model 8G005YTZ1. Let me find that on the internet. YTZ1. Yep. Okay, I got the schematic already on my computer. Seems like a fairly popular radio. I'm just getting it on Google Images. Yeah, check it out. That's the same radio. Alright. Exact same rig. Let's get the schematic for it. Oh, yeah. That looks like a good schematic. Okay. Oh, I have to buy it? That's ridiculous. That's not it. I wish that radio came with a schematic for it. Let's just download this image. And we'll just look at it on Windows Photo Viewer. It's a GIF? What in tarnation? Well, let me zoom in on it. That's weird. Maybe it's a GIF. This looks like the right one. I can't really see it. Okay, this looks like the right schematic right here. Now I can save the schematic. Maybe print it out. Create a free account. No, I don't want to create your free account. Let's see if we can see the schematic now. Alright, this is what I'm talking about. Now we have a schematic up. Thanks for being patient, guys. Okay. Oh. Just give me a second, guys. I should have done more prep work, like y'all are saying. What I need to do is go get my mouse. That'll make that easier. Oh yeah, now that I have $20, I can buy schematics. You're right. Well, I can look at this schematic on here for free on Google Images. Let's see. Okay, so we have our power input. We have this switch. This is the weird switch. So there's plenty of rectifier in here. That's not true. There's a rectifier tube in there. Got another switch. Oh, here we go. There's 4 capacitors. 4. Oh, yeah. Wait, let me make sure this is the right one. There's nowhere on here that says Zenith. Oh, wait. Oh, we have a chassis and a B minus. There's a B minus in a chassis. That's interesting. So we have the B minus is a rake ground. So yeah, that's very okay. So we have B minus is the rake ground, and then we have 3 capacitors on here. Oh, how is that supposed to work? Just a second. I'll be right back. Just a second. Alright, I'm back, guys. We're going to take a quick look at this schematic more. So I'm looking at this capacitor, and from what I can see, it only has 3 leads inside it. So we have 3 in the inside and the 1 on the outside. And the outside one I think is B minus is B minus. And we have only 3 capacitors. Interesting. But on here, we have 4 capacitors. This is a US radio. This is for sure a US radio. So this is interesting. We got the okay, let's find the other capacitor. Where is the other capacitor at? Where can you be? So we have the first capacitor right there. Where's the second electrolytic? Here's all those switch contacts with all the different inductors for the different bands. And all the antennas on there, all the loop antennas, those things. We got our 1, 2, 3, 4, 5. That's a super heterogeneous. Oh. This isn't the same radio. Look at this one only has, this one has a 3v4 tube right here. And in the actual tube radio, this is only a single-ended amplifier. In our tube radio, we had 2 power amplifier tubes for the push-pull. So that's the wrong schematic. Will this schematic be right? We have 1, 2, 3, 4, 5, 6, 7, 8 tubes. This one is right. Sorry about that. We're going to visit this website. Yeah. Oh, look, you don't even have to pay, and they let you look at their thing. Oh, you only have to pay if you want to print. That makes sense. So I can... Is Antique Radio Schematics a good one? Let's see. Is that a website? I don't see the website for that, dude. I look up Antique Radio Schematics, and there's no websites that are titled that, if you want to help me out there. Sorry for the stupid scrolling on my screen. That's the issue. So we have power amp. Okay, we got our 2 power amp tubes. Let's take a look at the capacitor. Oh, yep, we got our 3 capacitors right here. I have to tilt my head to look at this stupid thing. I can't get their dumb print to spin around. Okay, so we got our capacitors right here. It doesn't give us... Oh, this is annoying. Doesn't give us... Oh, we have our parts list over here. That's hard to read. I love this job of restoring tube radios. Such a pain sometimes. So we got our electrolytic capacitors here. We have C30, C31, and C32. Oh, we have our C33. Oh, so these 2 capacitors on here is the other capacitor. Let me just make sure that there's no more electrolytics in here hiding. We got a lot of capacitors in here. Yeah, I think we have just these 5 are the 5 electrolytic capacitors we need. Oh yeah, that makes sense. If you look over here, I'll show you something cool. If you look right here, the flashlight, this capacitor although it has more wires going into it, only has 2 contacts in the actual capacitor lead. We have the ground on the side. We have our 2 capacitors. We have a lot of grounds. Let me just confirm that these are actually grounds. Yep, those are grounds. That's B minus, not ground. It seems like they wanted to keep a floating power supply. A floating chassis. It's interesting. Chassis ground isn't the same as normal ground. What the heck? Look at this filament. The filament inside this tube is turned bright white. It's not normal. Yeah, I can replace these. So let's see what values these capacitors are. Because we're going to need 5 capacitors. I should probably be able to run this radio after just replacing electrolytics. We have 30, 31, 32, and 30 through 34, basically. This is hard to read. We have 40 microfarad, 20 microfarad, 10 microfarad. C33 is 200 microfarad. At 10 volts? That doesn't seem right. We have 34. So 40 microfarads, 20 microfarads, 10 microfarads, 200 microfarads, 40 microfarads. Let's see which one is 200. That's 33. Yeah, well, the issue with the list is that it's just a pain. Oh, it says it right there. 200 microfarads. Oh, it says it right here. 20, 40, 10, 234. Wow, that would have been helpful to see before. I didn't read those parts. Okay. I may not have those. IZ117Z6G tube, that's probably this one. I have a Z3. I guess they're using a different rectifier in there. Maybe that's the wrong rectifier, someone put the wrong one in. I wonder how the heaters are wired up. I bet they have a resistor going to the heaters, or filaments. Interesting. So, let's see. We got these detector coils you can pull out. We got the capacitors. I'm halfway tempted just to fire it up and see what happens. See if all the tubes line up at least. Make sure that that works. I'm going to get an extension cord to cut apart to stick in there. Just a second. I'll be right back, guys. Okay, just... This is a pretty interesting thing in here. So we've got these 2 electrolytics we'll probably replace. The electrolytics are more than likely bad. So we got this going halfway through the resistor to that capacitor. Halfway through the resistor. Also got a fat resistor going to one of the tubes. So that fat resistor going to one of the tubes is more than likely going to be this 68 ohm resistor. So I bet if I test this resistor, it's going to be 68 ohms. You will. Yeah, here we go. Yep, 60 ohms. So this wire, this capacitor right here is the 40 microfarad capacitor. This next one, this second one right here, is going to be the 20 microfarad capacitor. And the final one, this bottom rig, it goes up to the switch. I don't know where that one goes, just a second. That one goes someplace weird. That one powers the screen grids of one of the tubes. What's the resistor? Okay. Yeah, I'll have to replace that. Oh, that's annoying. Let me turn off my soldering iron. I may just end this live stream now. It's gone on a long time, and there's only 14 people watching. Yeah, I'll replace the electrolytic caps, and I'll monitor the current flowing through it. Actually, I think I have a current meter down here that I can just measure the power flowing into it. This is a safety precaution. Here, hold up. So I've got a pretty cool little current meter right here. And we'll measure the current flowing into this circuit. And if the current goes past 2 amps, then I'll kill it. Because we know it's screwing something up from the bad capacitors. Let me see. Yeah. These are 3-section capacitors, and they have a common terminal right here. And all these wax ones are a real pain to replace, too. These ones should probably be good. These ones are probably good. I'll just check for shorts. Yeah, let's check the capacitor and see if they're shorted. No shorts. You can hear the speaker when I put my multimeter wrong. This one. That's an audio capacitor for sure. This doesn't test for leaky capacitors, but I'll test for shorted ones. Oh, sick. There's oil dripping out of that one. Nasty. Nothing. So far, all is good. In capacitor land. Well, the capacitors look good, I guess. They don't look shorted, at least. The electrolytics, I can't say the same for. I haven't tested all of them yet. They're more than likely leaky. Let's test the resistance of this electrolytic capacitor. Open. Got a few mega ohms on this one. Oh, dang. That one's 6K. One of these capacitors is pretty bad. Well, cool. I'm tired. Wow, wow. Everything else in here looks fairly good. Hey, look, there's your circuit board. That's a circuit board, all right. Not the one we think of, but a circuit board nonetheless. More like a switchboard with a bazillion different tuners on it. No, the amount of engineering that went into building this one radio is crazy. Yeah, I have a variac up here where I can slowly turn up the AC input, so I'll probably use that variac combination with my current meter to run it up and just make sure that it's not gonna kill too much current flowing through. But first of all, I'm probably gonna replace these 2 electrolytic capacitors or 5 electrolytic capacitors, which is a job in itself. But after I get those fixed, then it should be good. Let's see, I have some electrolytic caps right here. Let me find them. Okay, now what is the voltage ratings on this schematic? All these are less than 200 volts. So check this out. I have these capacitors right here. These are fairly small. Each of these is 10 microfarads at 200 volts. So let's say I need to get my 10 microfarad capacitor in place. Well, yeah, I have a 10, a 20, and a 40. So I can just put 2 of these together for 10. I mean for 20, one of them for 10. For my 41, that's a little bit of more of a pain. Let's see, do I have any 40 microfarad caps? 200 volts. No. I have this cap. This is a 68 microfarads, 400 volts. I got 120 microfarads. Anyway, I'll replace the electrolytics with these electrolytics down here. It's crazy how small they can get now. I can probably just put a lot of these in parallel and call it a day. That'll work fine. Because just 4 of these together equals that right one. For the 200 microfarad one, for my 200 microfarad cap, I'll use that. Wait a second. It only needs to be a 10 volt for the 200 microfarad cap. That's interesting. Like 150 volts for the other ones. I wonder if I have any 150 volt little caps over here. I'll replace those. Let's see. Just past midnight? So where are you guys all at? Okay. Oh, cool. UK? The 10 volt one. Alright, thank you so much, guys, for tuning into my live stream. 11 p.m. Oh, cool. South Africa? Oh, that's awesome. Claude van der Rest. That's pretty cool. Alright, guys. So, my battery in my phone is about to die right now. And, I kind of want to do one more thing for y'all before I shut down for the day. Because my phone battery is going to die in just a second anyway. So, I'm going to put away this tube radio. I'm going to work on it. But I'm just going to work on it not on live stream. And then I'll make a video of it turning on if I get it to work. Or I may even do another live stream. So do you guys want me to blow up any capacitors or anything? Or build something real quick before the my thing runs out on my battery? Any suggestions, or do you just want me to blow up a capacitor? Capacitor? Yes or no? blow up a capacitor. I guess it's like a signature Tech thing. Gotta blow up one capacitor. Sandwich and capacitor. So we got our fan running up here. Alright, here you go. As always, thanks for watching and blow up the capacitor. This capacitor should blow up nicely. Alright, guys. You wanted this, not me. I guess blowing up a capacitor is like a tradition in my live streams. Here y'all go. Come on. You can pop. She gonna blow up? Oh! Well, she blew. Smells bad. Okay, my phone is about to die. I'm running out of low battery right now. You look at, we'll feed these little things into the fan. Alright, well, now that everything is a mess because that capacitor blew up everywhere, there's what's left of it. Turn off the fan. Well, that's the video. So, thank you for watching the video about the tube radio. I guess I didn't have time to completely fix it in this video. Restoring a tube radio like that takes a lot of time and a lot of work, because just imagine how long it took to build it. You have to replace a lot of those capacitors that blew and find those capacitors in addition to that. But I enjoy fixing tube radios, and I hope I entertained you all in this video. I had some fun. I got to do the capacitor explosion, which is signature in all my videos, and I had a lot of fun fixing that radio. So there will definitely be more videos coming out about fixing that tube radio, because it will get fixed, and I will make a video about it warming up, whether or not it breaks or not. But thanks for watching, and stay tuned for next time.